Surprise.
He did the mash.
He did the Monster Mash.
The Monster Mash.
It was a graveyard
Alright, there we go, the Monster Mash.
It caught on.
Sullivan, I'm so over my Aliens theme. This is no longer Aliens. He wanted to show you that, you know, his Halloween costume, he was an alien. Nice job. Toy Story right there. That was his Halloween costume. Very nice, Mr. Sullivan. I'm now on to hilarious jokes. Hilarious jokes. Pentagon, hexagon, Oregon. Hilarity. That's not really a polygon. But we are talking regular polygons. These are regular polygons. Regular pentagon, regular hexagon. Oregon is a state. Let's get rid of that. Here we go. Now let's get started. Alright, so we're going to find the area of these bad boys. It can get kind of tricky in here. So we got some definitions to write down and whatnot. So what is a regular polygon? Well, it's a polygon. What's the key to this? All sides are congruent. All sides are congruent. So I know that this side is this side, is this side, is this side, is this side, is this side. Excellent. So something we're going to do here, this is a six-sided, so this is a hexagon. So we've got our hexagon right here I'm looking at, and a couple different things with this hexagon. We're going to say that the hexagon is inscribed in a circle. So it's inscribed in a circle. You can also say circumscribed. The circle circumscribes the hexagon, but I'm going to say it's inside, so we'll use inscribed. That's pretty cool, and I'm going to get some definitions from that. And then I went any farther and drove it into the hexagon into little triangles here. So let's get some definitions of things we need to know with this. So hexagon has a center. Regular hexagon has a center. And from this center, I can go straight to one of these sides right here. It makes a right angle. This is called the apothem. And what this does is it goes from the center, and it's a perpendicular bisector of the side. So it's a perpendicular bisector of one of the sides. So what does that mean? It means this is congruent to this is congruent to this, it makes a right angle. A lot of times we will use a dotted line for this. So it's almost like the height, when we draw the heights in a triangle, and it makes that nice right angle there, and it cuts these in half, so that's cool. So if every side of this is like 6, 6, 6, what does it do to here? It makes it 3 and 3. That's going to be huge coming up because the whole side is 6, so it cuts in half. Huge. Also from this, we can draw from our center, we can go to any one, boom, like this. Something like that. What this is it's called the radius. So I would write this right in there. That is called the radius. Boom, right there. And look, it's the radius of the circle. It's the same thing. So that is the radius. I can draw two radius, which would be radii, and I get something like this. And look, it makes a triangle in there. So that's going to be important. Also, another important thing is called the central angle. When I do this, it creates a central angle. Can you see my central angle right in here? Boom, there it is. So I've got a bunch of these. I've got 6 central angles. So if you look at these angles, we can call them X. They're all the same. If it's a regular polygon, all these central angles here are all the same. And finding these is going to be hugely important. How do you think I go about finding these? Well, I can say, all right, what is a circle? How many degrees is a circle? It's 360 degrees. So what is each one of these? Well, how many do I have? I've got 1, 2, 3, 4, 5, 6, just like my sines. Divide that by 6. So every one of those is a 60-degree angle. So when I do this, I break this into 60 degrees, 60 degrees, 60 degrees, 60 degrees, 60 degrees. That adds up to 360, so I'm good to go. So if I look back to my original picture here, this is my original hexagon. I threw the circle around it so we could see the different parts. But basically, if I want to find the area of this, what am I going to do? I'm going to find the area of these triangles. So here's a triangle right here. How many triangles do I have? I've got 1, 2, 3, 4, 5, 6. So all I got to do is take the area of one of these triangles, if I can find the area of something like this, and times it by 6 because there's 6 of them. What's the area of a triangle? It's just 1/2 base times height. So all I need to do is find my height. In this case, it's A. It's my apothem. So a lot of this is going to be finding out the apothem here. So that's such a key new term for us, which is like the height of one of these triangles. Then we're going to times it by the number of sides, times it by the height. So that's regular polygons. So make sure you know apothem, what a radius is, and a central angle. If we can find these, we are good to go. Also, I didn't say it, but you know, each one of these is also called a side. Like the side of this was 6. So each side, there's 6 sides. So let's use this to see if we can come up with it. So how do we do this? Well, the area of a regular polygon is going to be this. It's going to be 1/2 your apothem times the perimeter. And the perimeter is just the number of sides times the length of the sides. So we're dividing it. That's like our triangles. It's just like 1/2 base times height. 6 triangles. In the last case, that gave us like our perimeter. So it's really just the triangle thing. I'm just adding up all my triangles. So can we do it? Let's check this out. What do I know here? Well, I know my apothem is what? 11. There it is drawn in there. Remember, it cuts it in half. It's from the center. It makes that right angle. And I know my side is 8. If I know that, can I do it? Sure. Area just equals 1/2. My apothem is 11. What's the perimeter? Well, if that's 8, this is 8, this is 8, this is 8, 8, 8, 8, 8, 8. How many sides is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to say my perimeter is 9 times 8, which is 72. And then I can plug that in as my last thing. So P is perimeter. So in my formula here, A is apothem, and P is perimeter. And if you want, you can think of your perimeter as the number of sides times the length of your sides. Excellent. Very good. So now it's just a matter of, we can really just go straight to the calculator here if you want and just multiply it out. So it's going to be 0.5, 1/2, times 11, times 72. And we get 396. 396. And we don't know what it is. It's not labeled feet, inches, or anything like that. So I'm going to say units squared. Fantastic. So they start off pretty great. If they give you everything, it's great. Now it turns into a puzzle, though. We got to find all the missing pieces. We need to find the A and the P. So check out example number 2 over here. Do I know the apothem? No, I don't. Do I know the perimeter? No, I don't. So I'm going to start building little triangles in here. So if I look at this, you can draw them however you want. Boom. Or maybe you want to draw it this way, but that's 13. You know, all the radii are going to be the same, 13, 13. Now let's draw in our apothem. So I'm going to draw that in, and it looks something like this. So if you want to redraw your triangle, you can. So my apothem is that dotted line, and I know the radius was 13. I know it's my right angle. Can I find it? Well, I need a little more information. Luckily, it's a hexagon, and we just did this before. What's the measure of every central angle? Wasn't it 60 from our last one? If I go back to this, didn't we say each one of these had to be 60? So I just took 360 divided by the number of sides, and it gave me that. But check this out. This splits it in half. If it's a perpendicular bisector, it's also the angle bisector. So this becomes 30 and 30. Kind of hard to see over here. Let's put in this triangle, though, so we can really see it. It cuts those in half. So really, I'll relabel that. We know that the central angle was 60, but when I draw in the apothem, it cuts it in half, so my 60 becomes 30 and 30. Fantastic. Now I can do some work here. If you're really good with the trig, chapter 7, the trig stuff, you can do the trig stuff. We're really looking for this side and the apothem A. I'm going to call it Y. So I need to find both parts of this. This is actually a special right triangle. We've got a 30, 60, 90 here. So if you like the 30, 60, 90, remember this was radical 3. No, that was not radical 3. Just kidding. What was that? It goes small sides 1, big sides 2, medium sides radical 3. So really, if you're good at that, you can separate proportions. If you prefer trig, we can go straight to trig. It doesn't matter. In this case, let's do some trig action. It would be the sine of 30 equals what? Opposite over hypotenuse. So that would be x over 13. So if you like the exact values and you have a 30, 60, 90, go for it, man. You like the exact values. You're going to get 13. That's half of it. So x is going to be 6.5. But the calculator would have told you that too. If you solve this, you get 13 sine of 30. So if you like the proportions, if you like the calculator, you could have done the calculator, sine of 30. And there it is, 6.5. So either way, 6.5. So x is 6.5. What did we just find? We found this little chunk right here. This bottom half of it. And if that's 6.5, what is this over here? This is also going to be 6.5. Interesting. So now I know that each of those are 6.5. Now y is the apothem. So what can I do? Well, you can do cosine of 30 equals adjacent over 13. Or if you use your special case here, you're going to put radical 3 on it. So it's going to be 6.5 radical 3. So if you're really into exact values, the y is going to be, I should probably call it 13 halves radical 3. Would probably be best. If you want to go straight to the decimal, I'm going to go straight to the decimal. 13 times cosine of 30 will give me 11.26, let's say. So I'm going to round it. But that's a pretty good approximation. 11.26. So that is the y value. So that is what we found here is 11.26. Holy cow. Finally, all that so I can now do the problem. I can say area equals 1/2. What's my apothem? It's 11.26. So when I redrew the picture over here, that was my apothem, the dotted line, the dotted line. What is the perimeter? Well, check this out. This is 6.5 from here to here, 6.5 from here to here. So what's the total distance from here to here? It's 13. And if that's 13, we got 13, 13, 13, 13. We got 6 times 13. What is 6 times 13? It is going to be 78. Excellent. So we've got that going on. Now let's go calculator. So it was 0.5, 1/2, times this number here, 11.26, times it by, what do we say the perimeter was? 78 when you add them all up? 439.14. I love it. 439.14. Again, there's nothing here, so I got to go units squared. Wow, that's intense. That's a lot of work. So, yeah, it can get tricky here. You got to use all your tools, whether it's trig, special right triangles, Pythagorean theorem. We're bringing it. All right. Luckily, though, we're going to focus on the measure of these central angles. We're only going to focus on hexagons, which we've just done, triangles, squares, and pentagons. So, basically, let's just do this right now. Let's get an idea. Here's the center of a triangle. When I draw in it right here, what is the measure of this central angle here? Well, how many of them are there? There's three triangles in here. So take 360 divided by 3. What is x going to be? 120. So if you're given a triangle, you know right off the bat this is going to be 120. And what's cool about this? What happens when you draw your apothem in there? If I draw that in, what does that do to that 120? It splits it into 60 and 60. So again, you're looking at 30, 60, 90 triangles. Super cool right there. How about square? Here's the center of a square. Drawing my radii. Boom, boom. Or look at that. That's not too. Oh, I got cocky. I got cocky right there. Let me erase that. I thought I had that one line was like perfectly straight, and then yeah. Oh my gosh, I'm having issues. Hopefully yours looks better than that. But again, it doesn't matter. I've got 360. How many central angles do I have? I've got 1, 2, 3, 4 central angles here. So divided by 4. What are each of these? These are all 90-degree angles. Holy cow. And maybe we remembered that back from Unit 5 with the quadrilaterals, that these are all right angles. These are all 90. Now, if I drop the apothem in that, what's it going to do? It's going to split that 90 into half. Oh my gosh, it gives us 45, 45, 90. Isn't that cool? Very, very cool. So, you know, triangles are going to give us 30, 60, 90s. This is going to give us 45, 45, 90s. What is the pentagon going to give us? I don't know. Let's check it out. Draw in the center of this, and I'm going to draw in my radii. There's one, there's another one, there's another one, there's another one. And again, I've got 5 of these, so we're looking at 360 degrees would be the whole circle. Divide it by 5. What am I going to get on this one? I think we're going to get 72. 72 degrees is each one of these. What happens when you divide that in half? I'm trying to get a different color here. If I drop my apothem in here, what's half of 72? Well, it's 36. Is there anything special about that? Nope, you're going to have to use trig in this case. So now that triangle is going to force you to use trig. Again, if you like trig, it's flowing. Just use it the whole time. We're not going to make you do exact values. You can go straight to decimal. If you like the exact values, it's good for SAT, and sometimes they'll leave it like that. You can do your exact value. So the choice is yours. Fantastic. Killing it. So I put a little review. Here's what we need to know. All these little things will help us solve these. So this is Chapter 7 big coming back at us. Let's try it. Find the area of the following. So we've got an octagon with an apothem of 4 feet and a side. You know, I think I may make you draw it at some point. What is an octagon? Well, it's a stop sign, isn't it? And that is the worst looking stop sign I've ever drawn. Are you kidding me? Wow, I gotta try again. You know, I can't let that happen. Up, over, flat, over. There we go. All right, not amazing, but it gets the job done. So as long as you draw an 8-sided figure, you're cool. So if I draw in the apothem, I usually bring mine straight down. I know that's 4 feet, and I know a side is 6. I've actually got all my information. The cool thing about this is our formula is always the same. It's always 1/2 apothem times perimeter. So what's the apothem? It's 4. What's the perimeter? Well, I've got 8 sides. There's 6 of them. We're talking about 48. So that's not a problem. And then it's just a matter of multiplying these out. Half of 4 is 2. 2 times 8 is 96. And this is in feet, so make sure you label it. It's feet squared. Fantastic. All right, so I like when they give it. When they give it to you all, just plug and chug. Now they're not giving it to me all. So let's take a look at the triangle. What can I do with this triangle? Well, we just talked about the central angle. If I do the central angle, what was it? It was 360 divided by 3, which was 120. And if I draw this in, I'm going to cut 120 in half, so I'm really looking at a 60-degree angle. And again, it's just up to you. Do you want to use your special triangle? If you do your special triangle right below it, we're looking at the big side is 2, the small side is 1, the medium side is radical 3. So to find my medium side, I'm sorry, small side, if that's the big side's 10, what's my apothem? It is going to be 5. If you don't like that, trig it up, man. What is the trig of this? What is 5, or I'm sorry, this missing side would have been cosine. The adjacent cosine of 60 would be your adjacent, your apothem over 10. It gives you the same answer. How about this to find the other one? If you want to find this side over here, let's call it x. You could say the sine of 60, opposite over, so we can say x over 10. Now it's going to give you a nice decimal. If you layer into exact values, you're going to realize, oh yeah, I know what x is. X is going to be 5 radical 3. Very nice. So either way, decimal or that. The thing is, that's only half of it. That's this half over here, but it's congruent to this half. So if half of it is 5 radical 3, what is the whole thing? I was trying to grab the... There we go. If half of it is 5 radical 3 and another 5 radical 3, can we add them together? Sure, the whole side, when you add them together, will be 10 radical 3. So now you can go to your formula, 1/2 apothem times perimeter. And let's put them in here. If I say 1/2, the apothem was 5. The perimeter is 10 radical 3. Well, this is 10 radical 3. The bottom is 10 radical 3. So what do I got? Times them by 3. I've got 30 radical 3 right there. Wow. Add them all up, or 3 times that. And now I'm going to go calculate, or if you want the exact value, no problem. You can just say exact value. Half of 30 is 15. 15 times 5 is 75 radical 3. Now, if you're not down with that, I'm okay. That's okay. And this is units squared. If you want to go back to this x, this sign, go back to that. You know, if you like that, we're going to say that what? X is 10 times the sine of 60. And then just try to round this the best you can. This is 8.66. So 5 radical 3 is really 8.66. So when you're back at your triangle here, wow. And I found this. This was 8.66, which means this is 8.66. So the key is, what are you doing? You have to double this. So 8.66, 8.66, double it. This will give you your side. Your side is really 17.32. So you can use 17.32. So we're going to plug in, the side is 17.32, but this is also 17.32, 17.32. So you got to add up all those sides or times it by 3. So let's clear that out. 17.32 times it by, there's 3 of them. This is really our perimeter, 51.96. So make sure you put in the perimeter, 51.96. And now it's just a matter of multiplying this out. So go back to your calculator. We're going to go 0.5 times our apothem, which is 5, times 51.96. What does that give us? 129.9. So again, this is the approximation. I think it's going to be a very good approximation. We barely rounded at all. So we've got this. How does it compare to the exact? Let's check it out. If you did the exact, use your special right triangles, never rounded at all. If you wanted to make it a decimal to compare, look at that, 129.9 versus 129.9. So we're, I'm very good with using the trig and doing a little rounding. Excellent job finding area. 2 more. And all right, here we go. So 2 more. Video's getting kind of long here, so I'm just going to post the answers here. Pause it, try it. If you get the answers right, I think you're good to go. Go to the mastery check. If you pause it and then you don't get these right, I'm going to throw the step-by-step solution. So I'll work these, but it's going to be in a separate video below. So if you've got it, move on. If you need a little more practice, watch the one. It'll be below the application walkthrough. Good luck. Peace.